Okay, so I just want to briefly go through this. Okay, we're not quite done yet. So, for those of you tuning in later, okay, we just threw this problem up on the board and threw it up here and it's stuck. Okay, so it says the Air Force will test the power of rockets, which I'm presuming that they do. It would make sense that either the Air Force or the Army is probably going to do a lot of the testing in bunkers on what these munitions will do. And they crash them into a bunker while moving along railroad tracks. The distance of the track is 710 meters, which the ignition point, when the time started the rocket, was moving at 205 meters per second. At impact, 1.55 seconds later, the 1,100 kilogram rocket was moving 610 meters per second. So what is the power of that rocket? Okay, so then as we said in class, probably for, I said 30, we got to be getting close to that. Well, 28 or 29 times we said the next thing you should do is write down what you know. Okay, so I wrote this up here right-handed, and then I wrote everything up here left-handed. You can see how neat it is. I thought that was funny. Okay, see, zygomatic bone, okay? Zygomatic bone, masseter, buccinator. This will pull the sides of your jaw up. You will not break your face if you smile. No matter how hard you try, you will not break your face. Okay? So as we have this wrote down where it belongs, the distance was 710. So this ignition point, how do we tell the difference between final and initial velocity? A lot of you analyzed this correctly and said, well, this ignition point, when the time started, this is how fast that rocket was moving. Then on impact, it says 1.55 seconds later. Holy cow, you throw the boosters in on that rocket, now it's really moving down the tracks and crashes into the bunker because it went from 205 to, 610 meters per second in not a whole lot of time. Now, is this accurate? That I really don't know. Maybe it is, maybe it isn't, but the process of solving these would still be the same because we want you to have a good foundation moving forward. So what do we need to know to solve for power? Not wait. You need to know the work and how efficiently is it getting it done. Okay? Then what do we need to know to solve for work? Not time. You need to know force and distance. So we have none of that. So that's why we have all these question marks in here. So the first thing you need to do is solve for, what are we doing back there?
My pencil got dropped on the floor.
Okay. All right. So the first thing you're going to want to do is find your acceleration, and that's what we had done. Okay. So then once you have your acceleration, you have to find force. We said we could break this up into different bits and pieces, but you have to find force anyway, rather than asking what's the force of the rocket. Okay, so you have your acceleration. You take that times your mass that is known. That gives you your force. We need to find work, which means you find your force. You take it times that known distance, which was 710. And that gives us our work here, which is 204.067490. I don't know how well that shows up on the camera, but we're doing the best we can. And then once you have your work, you're on the final step. Because what do you divide your work by? Once you divide it by time, now you have power. There's one more thing that we could solve for this, because it's not a big stretch to go from this variable, which is power, to what we did yesterday, which is what? Horsepower. So what extra initials or what extra step would you take? Yeah, divide by 746, and that would give you your horsepower. Okay, front row, right side. In the middle here, front row. Okay. Okay, then front row, left side. Okay, the middle. And back. And back. And back. Okay, so problem quiz tomorrow. If you do not have a formula sheet, we're not going to put them up on the board here anymore. That's part of responsibility. So we hope that you can remember them then, because we are not saying that you can't use a formula sheet. You can if you have it. And if I lost mine, if I left it at home, that's just part of responsibility. I'd be willing to bet, do a lot of you have your formula sheet in your spiral notebook? Or is it on a separate piece of paper? And if it's on a separate piece of paper, that's fine. If it was in your spiral notebook, then it's not going to become detached and fall in other places. But some of you probably already know these just because you've used them so many times. Does that sound right, maybe? Okay, so that's all I have. Again, problem quiz tomorrow. And then next week, we have some good distractions next week because of, thanks to our varsity ladies volleyball team. So moving forward, I'm not quite sure how next week looks. We will probably start reviewing and have an exam possibly next week. There's 2 parts exam. I don't know which one we'll get out of the way first. We'll catch up to you next time.